So in this video, I'd like to explain about some of the special cases of atoms when it comes to giving away or taking in electrons. I'm going to start with this first one, which is carbon. Carbon has 6 electrons. And you notice that 4 of those electrons are valence electrons. This outermost electron layer is exactly half filled. So carbon has a choice. It can either take in electrons, taking in 4, to give it a complete outermost layer, or, restarting with the original carbon atom, it can strip away the second layer, giving away 4. 1, 2, 3, 4. And once it's given away 4 electrons, that exposes the complete layer underneath. Now, in the notes, I explained that atoms will try to move as few electrons as they can to get the complete outer electron layer. So in the case of carbon, we're in an interesting situation. It can either gain 4 or it can lose 4. So whenever you have a half-filled outermost electron layer, the atom will actually do either. I like to compare it to an ace in the card game blackjack. The ace can either be a 1 or an 11, depending on what the other cards will be like. Likewise, when it comes to elements like carbon that are half-filled on their outermost electron layer, they can either give or take electrons, depending on what the other elements around them want to do. So that's the situation with carbon. Likewise, you could do the same thing with the element silicon. Silicon has 14 electrons. So here's our model of a silicon atom. Once again, you notice there's 4 valence electrons. It can either take in 4 electrons, or it can give away these 4 valence electrons to expose the complete layer underneath. So once again, silicon can either give away 4 electrons or take 4 in. It can do either. A final unusual situation is hydrogen. Hydrogen has only 1 electron. Now in the case of hydrogen, it has a choice. If it takes in 1 electron, that will allow it to have a complete first electron layer, which is good. But it turns out that if it gives away this 1 electron and it's left with 0, that counts as a complete outer electron layer. It makes that atom happy as well. So hydrogen atoms are the only ones that will give away or take in only 1 electron and end up with a complete outer electron layer. It makes hydrogen unique, and that happens only because its first layer has enough spots for 2 electrons. Finally, if I use helium, which has 2 electrons, you notice that complete outermost electron layer is already there to begin with, which means that atom will do nothing. Likewise, neon, which has 10 electrons, also starts with a complete outer electron layer, so neon atoms will do nothing as well, and 18 with argon.